I will go over some conversion from polar to rectangular equations and rectangular equation to polar equations. Now, in between, I will mention common polar graphs. Okay, some simple one. For example, the first one, what if R equals to constant? If R equals to constant, what does it mean? Actually, I don't call this example one. Call this the first common graph. Suppose, for example, when I say R equals to 3, what does the graph look like? The first, we can interpret that quite easy. This is all the points whose distance from origin is 3. So suppose I have a rectangular coordinate system. It refers to a situation where the distance from origin to every point is 3 units. Okay, so of course then we can tell right away the equation, it is a circle, right? It must be a circle centered at origin with radius 3, whose equation is x squared plus y squared equals to 3 squared. Now, that's if we can interpret that though. We need to anticipate the situation where we may not be able to interpret that by just looking at that. So we need to learn how to convert this r equals to 3, into a rectangular coordinate equation. Okay, now keep in mind that we have this in our toolbox. R squared equals to x squared plus y squared. X equals to r cosine theta. Y equals to r sine theta. Okay, and then tangent theta is y over x. Okay, those are our toolbox. Okay, so we will try to, it's not always doable. No, it's not always doable. But for the ones you see in this class, will be doable by doing the following. For example, r equals to 3. If I square both sides, I get 3 squared, right? And then using the yellow one, I get x squared plus y squared equals 3 squared, which is, you see, it's the same to this one. Right? Now, with this said, then, what does this r equals constant represent in our graph? R equals constant will give us a circle centered at origin with radius constant. Whatever the constant is. Now, the thing is, this actually still work for r equals to a negative number. Even if I say r equals to -3, right? And r equals to -3, it still gives us the same circle. It still gives us the same circle. You can try you doing the table though. If I do the table, right? When theta equals to 0, my r is -3. When theta equals to, let's say, 45 degrees, the r is -3. 90 degrees, the r is -3. such that if I do the coordinate system, let's say this circle here, then when theta equals to 0, I go -3. This is when theta equals to 0. The theta equals to 0 refers to this direction. But because the r is negative, I shoot backward. When theta equals to 45 degrees, this is the direction, okay? But I shoot backward 3 units. So for 45 degrees here, I shoot backward 3 units, and so on and so forth. So you will see eventually I will get, when theta equals to 0, I get this point, 45 degrees this point, 90 degrees this point, 135 degrees this point, 180 degrees this point, so on and so forth. So I will still get the same circle. I will still get the same circle. Okay, that's one. For theta, for r equals to constant. Now, what happens if the second group, what happens if the theta equals to constant? Instead of the r, it's the theta equals to constant. In fact, this one is very important. This one is very important. Theta equals to constant. Let's say, for example, theta equals to pi over 6. Theta equals to pi over 6. What will the graph look like? The graph will look like approximately as the following. The angle formed from the pole will be 30 degrees. Okay, in fact, I should extend this further here. Okay, the theta here is pi over 6 for every radius. So in that direction, the radius may be positive, or if the radius negative, you go that way. Okay, now the thing is, what is this equation? What is this equation in rectangular system? Remember our toolbox? Okay, our toolbox. If theta equals to pi over 6, then tangent theta will be tangent pi over 6. Why I use tangent? Because using tangent, I can replace that tangent theta by y over x equals to 1 over radical 2. Okay, so y equals to 1 over radical 3 of x. That's the equation. Now, the important part is pay attention to the slope of this line. Okay. This line is a line passing origin whose slope, the slope here is tangent theta. Okay, the slope is equals to tangent theta. Okay, the slope equals to tangent theta. So we can say when theta equals to constant, what does it mean? It means line through passing through origin with slope equals to tangent theta. Actually, do not underestimate this this one here, this theta equals to constant thing. Why? Because of the following. Note, the angle the angle formed by line L and positive x-axis is given by is theta such that is given by theta tangent theta equals to the slope. I don't get it, Thomas. What do you mean? Okay, suppose I have y equals to 2x minus 1. The graph looks like this. 2x minus 1 looks like this. Okay. The y-intercept is 0, -1, and the slope is 2. So what is the angle here? What is the angle there? Well, the angle there is such that tangent theta equals to 2. So the angle is tangent inverse 2. Okay, now suppose I want to make it a lot scarier. You don't need to know this, but it will be nice if you know. Suppose I have another line. And this line is y equals to 1/3 x plus 2. So what is the angle here? Let's call this angle alpha. What is the angle there? Tangent alpha equals to
1/3.
1/3. So alpha is tangent inverse of 1/3. Okay. Then a crazy person come and say, oh, can you find the angle here? Can you find the angle there? Let's call that angle beta. Notice that angle beta is actually the angle theta minus alpha, right? So if somebody asks you what is the angle between this line and that line, what you do is you take the tangent inverse of the slope, okay, and subtract them. Tangent inverse of 2 minus tangent inverse of 1/3. Bang, you're done. Okay, now notice that what I have done here actually coming from this simple question, this simple observation. I hope toward the end of this semester you notice one thing though, why a lot of students say Thomas class is so hard. Because in my class, you need to think. I do a lot of analysis here, okay? I do a lot of analysis here. I have heard some people actually make a comment, which I don't really like, saying that in Thomas class, I feel like I'm a dumb student.
Like what?
Like a dumb student.
Oh.
You know, here's the thing though, it's actually quite the opposite. Of course, you need to think, okay? And if you don't focus, you'll be lost. If you don't focus, you'll be lost. And of course, then you will feel that way. But can you imagine if I don't do analysis in my class? Do you think it will be easier?
No, especially for people that are going to take like calculus 2 and 3. Not.
maybe, but if this is the first time you take trigonometry, for example, right? And then you find it to be easy. Okay, so easy that a lot easier than how I bring this class. Then either that teacher is so good in teaching, or that teacher don't make you think. But the way my philosophy of teaching is, if a teacher doesn't make you think, that teacher basically consider you are dumb, such that that teacher do not think it's necessary to make you think. You're just a robot. You are someone that they tell you what to do, but you cannot think on your own. That's the actual meaning of making you dumb, right? If they teach you something that you don't need to think, you don't need to analyze, you're just mechanical, okay? Now, so treating you that way, that you don't need to think in my class, actually, what you call it, condescending? I wonder if I use the right word. Implicitly treating you as if that you are not someone who can think. No, that's not the way I see you. The way I see you is you are someone who can think. You are someone who can analyze. You have the potential to do very well. Okay. Now, for me to bring that potential out such that you bloom, of course, then I need to make you think a lot harder, of course, right? Not super hard to the point that it's impossible. But of course, I keep on pushing your limit, right? Okay, pushing your limit. But eventually, I bring out the best of you. Okay, otherwise, then I will be just somebody who not different from a textbook, right? A textbook you can read anytime you like, doesn't challenge you. That's not me though. That's so not me. Okay, the third one. The third uh, very common graph in polar is R equals to, let me use K sine theta, or R equals to K cosine theta. Let's say, for example, R equals to 6 sine theta. R equals to 6 sine theta. I don't think this is something we can interpret. I get the graph by interpretation the way we did those two earlier, right? The way we did those two earlier, I don't think I can do so. Okay, so I only rely on my toolbox. I have R here, I have only sine here. With sine only, I cannot do much. But if I have R sine theta, that R sine theta can becomes what? That's our toolbox. If I have R there, it will becomes R sine theta, which is Y. And imagine on the left-hand side, I multiply by another R. So basically from the original equation, I multiply both sides by R. Not squaring it, I'm not squaring it. I multiply by R, such that I have R squared equals to 6R sine theta. This will becomes my red color, my yellow color, and this becomes my green color. So on the left-hand side, I get x squared plus y squared equals to 6y. What is the graph though? Then going back to your skill in intermediate algebra, we set one side equals to 0 and then do completing the square. Do you remember completing the square?
Yeah.
Okay, I will complete the square for this. The leading coefficient for y squared has to be 1. And then you take the coefficient of the y, which is -6, divide it by 2, and then square the quotient. Okay, now that way, then I know I need to add both sides by 9. Okay, that's how I know I need to add 9 to both sides. So the procedure to complete the square again is the leading coefficient has to be 1. Then you take the coefficient of the y only, divide it by 2, and then square. Now then what will happen? We have x squared plus y minus 3 squared equals to 9. That is a circle. That's a circle centered at 0, 3 with radius 3. Now you will see these 3 here, and this 3 here is actually half of this 6. Okay, now let me ask you to try. Let me ask you to try another one. This time I use cosine version. Let's say r equals to, let's say 8 cosine theta. Convert to rectangular equation. Okay, let me give you 2 minutes maybe. Let's see what you get. I will multiply by r both sides, right? So r squared equals to 8r cosine theta. So the left-hand side becomes,
X.
no, left-hand side,
X squared plus y squared.
x squared plus y squared, and the right-hand side becomes
X.
8x. Okay, and then I will complete the square, set one side equals to 0. What number do I need to add?
You need to complete the square by 16. It's 16.
With plus 16. Okay, just in case you want to know, that's -8 divided by 2 give us that -4. -4 being squared give us that 16. Okay, now then we get x minus 4 squared plus y squared equals to 4 squared. That is a circle centered at 4,0 with radius 4. Now, here's the thing. Here's the thing. What I have done so far only give you, oh, this is the equation. If this is the polar equation, then this will be the rectangular equation. Now, the thing is, when we graph them, they're supposed to look the same though. We know the graph of this last one. We know what the graph look like. That's easy. But can we draw it from here directly? Can we draw it from there directly on the polar coordinate system? and get the same circle. Okay, that's what I'm about to do now. But before we actually do that, I want you to do me a favor. You need to have a hands-on experience here. I need you to create a table for r equals to 8 cosine theta. I want you to create a table. I want you to do this. When theta equals to 0 degrees, what is the r? 30 degrees, what is the r? 45 degrees, what's the r? 60 degrees, 90 degrees, 120 degrees, 135 degrees, 150 degrees, and then 180 degrees. Maybe we do one more, 210 degrees. Okay, I want you to find the values for each one of these. So please use your calculator. Please use your calculator. And so for example, let me pick this guy here. Okay, when theta equals to 68 cosine 60 degrees, I use my calculator, I will get that's equals to 4. Exactly 4. Nice. And this will be 0. And so on and so forth. Okay. If possible, you may want to find at 15 degrees, that's between 0 and 30. Okay. At 15 degrees, at 75 degrees, at 105 degrees, at 165 degrees. Okay, let me ask you to do that. And we will use our graphing paper very soon. But do that first. Do that first. Let me give you how many minutes? 2 minutes, 3 minutes?
3 minutes.
Last time we did this graphing, the coordinates, the position of coordinates vaguely. Right now, we put it into more detailed practice. Okay? I hope you can start, and I hope you have your printout already. Do you need more time to get the printout? Nobody say anything. Okay, I'll start anyway. So the first coordinate is 0 degree, radius 8. So at 0 degree, I go 8 units in that direction of 0. 0 degrees. 1, 2, 3, 4, 5, 6, 7, 8. So that's the position of 0 degree 8. This is 8, 0 degrees in polar, right? And then at 15 degrees is 7.7. At 15 degrees is 7.7. So when I going to this 15 degrees direction, I go 7.7. 1, 2, 3, 4, 5, 6, 7, more than half, 7.7. So it's here. Oops. 7.7 approximately here. For 30 degrees, is 6.9, almost 7. 30 degrees, 6.9. At 30 degrees, 1, 2, 3, 4, 5, 6, almost 7. And so on and so forth. Okay, I hope you can continue. I will continue too. At 45 degrees, that's 5.7. This is
How
the
many?
line. Repeat again.
How many of the sheets do you want us to print out for today?
I said try to get at least 5.
Okay.
Yeah. For 45 degrees, 5, is it 5.7? Yeah, 5.7. So 1, 2, 3, 4, 5. More than half, but not 6. So 5.7 across here. At 60 degrees, that's 4. At 60 degrees, exactly 4. So at 60 degrees direction, I go 4 units. 1, 2, 3, 4. At 75 degrees, that's 2.1. So a bit more than 2. 75 degrees, 2.1. At 90 degrees, that's 0. At the origin, right? So notice that if I connect these points here, let me use another color. Let me use green color. Yeah, if I connect these points, then you will see that from 0 to 90 degrees, I get this. That's from 0 to 90 degrees. Do you need more time, by the way? I wonder why my baby is around me right now.
Why his baby is. We can graph the rest while you go check on your baby if you want.
Sorry. Let me continue. When we get to, oops, what's that?
We're at 105.
Yeah, but what happened with my graph? Okay. Now, yes, at 105 degrees, I get negative 2.1. So you see the angle is 105, but I will shoot backward, right? Okay. So at 105 degrees, I will shoot backward 2.1 here. So this coordinate here is negative 2.1 comma 105 degrees. You see what I mean? That's the coordinate. Okay. And then what happened at 120 degrees? It's negative 4. So when I am in the direction of 120 degrees, I shoot backward 4 units. 1, 2, 3, 4. So I hope now you understand what I mean by shooting backward. You get the angle, but you hold your gun backward. Okay, so instead of shooting the person in front of you, you shoot the person behind you. Okay, I say it in a very bad way. Okay, next, 135 degrees, negative 5.7. 135 degrees, negative 5.7. Negative 1, negative 2, negative 3, negative 4, negative 5.7. So this coordinate here is negative 5.7. 135 degrees. For 150 degrees, negative 6.9. For 150 degrees, so this one here, 150 degrees, I need to go backward negative 6.9. So there will be 1, 2, 3, 4, 5, negative 6, almost negative 7. This is negative 6.9, 150 degrees. So it seems like it is located at 330 degrees, but that's because 150 degrees shooting backward. Okay. And last one at 135, 165 degrees. 165 degrees, negative 7.7. So 165, but I shoot backward negative 7.7. I will get here. And at 180 degrees, I get negative 8. 180 degrees, I shoot backward 8. It gives me the same thing that I had earlier. So I connect these points. Let me use a slightly different color. I will use blue color. Now I hope you see that circle.
Beautiful.
Right? Now, things to see is the following. The reason I asked you to go further, 210 here. When you go 210 degrees, you will shoot backward and you will hit this anyway, which we already had earlier. Okay, so you see this R equals to 8 cosine theta actually give a circle. Gives a circle, a full circle on 0 degrees to 180 degrees. You don't need 360 degrees to form this circle. You just need pi. From 0 to pi, it forms the circle already. Okay, from 0 to pi, it forms this circle already. I happen to have graphing calculator with me. I wonder if I can really use that. Let me see. Let me try it first. Okay, otherwise it will be quite embarrassing. I want to craft. Oh, I really forget how to use this thing. I need to find out later. I need to find out how to use this graphing calculator. I forgot how to use that thing. Yeah. So this gives us a circle. You can try later on with the graphing paper you have to get that the circle will be up here. You know, so you will see that, you will see actually the following. Maybe I write it as another note. So if you have a constant cosine theta, the graph will be symmetric to x-axis with respect to x-axis. because the function r depends on cosine theta only, Now, on the other hand, if it depends on sine theta only, any function, any polar function that depends on sine theta only, then it will be symmetric with respect to y-axis. Okay, now you don't need to know this now. In fact, I would like to say that I don't even think I will ask you to do graphing in a test. Given the time that I give you may not be enough. You may spend too much time in graphing. So I may ask you to graph as a quiz instead, take-home quiz. But I will do that next week after your test 4. Okay, right now we focus on how to convert equation in polar to rectangular so far. Okay, and later on some special equation in rectangular to polar. Let's do that one instead. So for example, the fourth case. What happens if we have x equals constant or y equals to constant? What will that be in polar equation? Let's say, for example, x equals to 5. Don't forget our toolbox. I will replace x by r cosine theta equals to 5. Now, it is a custom. Note, it is a custom to rewrite, if possible, to rewrite a polar equation as r as a function of theta. In other words, you isolate the r and the other side without r. Okay? Not all the time doable, but we try. If it is doable, then you need to. Okay, now in this case, we will get r equals to 5 over cosine theta, r equals to 5 secant theta. Okay, now that will give you a line. Okay, maybe another note. Oops. Another note. R equals to k cosine theta gives a circle. R equals to k secant theta gives a line. Is a vertical line. Okay. Now you try this. For example, let's say y equals to -3. What is the polar equation? This will be r sine theta equals to -3, r equals to -3 over sine theta. That's r equals to -3 cosecant theta. Right? As you can see again, r equals to k sine theta gives a circle. R equals to k cosecant theta gives a horizontal line. Okay. Now let's see. Suppose, for example, I go on further, but this tends to be on the easy side. Suppose, for example, I have 2x plus 3y equals to 5. What will the polar equation be? Now, what I want you to do is you change this according to our toolbox and change this according to our toolbox. Then factor the r, and then r equals to 5 over that ugly thing. Okay, now try. I'll give you maybe 2 minutes.
Can you scroll up a little?
Repeat again.
Can you scroll up a little bit?
Scroll up a little bit. Oh, okay. Is it enough?
Yeah. Yes.
And let me ask you to try this one also. Convert to rectangular equation. Rectangular equation. R cosine theta minus sine theta equals to 2. Okay, so the first one will take you 2 minutes. The second one should take you 2 minutes. Together with your break, let's come back at 8.5. This first. So this would be 2r cosine theta plus 3r sine theta equals to 5. Factor the r. So r is equals to 5 over 2 cosine theta plus 3 sine theta. Okay.
Is that it for that one?
Yeah, that's it. That's it. But if you are in my pre-calculus class, I want to do a bit more analysis from here. What is that? Let's try to sketch the graph. And what will 2x plus 3y look like? It looks like approximately like this. Where the x-intercept is 3, 0. The x-intercept is 3, 0, and y-intercept is 0, 2. One of the common question you get in calculus 1, actually, one of the common question, in fact, even in pre-calculus, is this question: the distance from origin to the line. What is the closest distance here? Okay, what's the closest distance there? Now, actually, with just a little bit more knowledge, we will be able to answer this quite fast from here. So basically, you rewrite that in the polar form, okay? And then Don't worry, you don't need to know this though. You don't need to know this. Notice that this r is actually the distance from origin to the line, right? Okay, so from origin to the line gives you this r. Depends on the theta though. Depends on the theta. However, if I can find the maximum value here, if I can find the maximum value here, then I will also find the minimum value for the whole thing. Right? Because if you divide by a larger number, the quotient will be smaller. Does it make sense? The larger the denominator, the larger the denominator, the smaller the quotient. Right? So I need to pin this. Okay. So this is what I will do. If we can find the maximum value of the denominator, then I can find the minimum value of r. Now the thing is, this guy here, if we graph that, it actually gives us a cosine function. It actually gives us a cosine function. Let me graph that for you. Let me graph that. What is that again? Y equals to 2 cosine theta
Plus 3 cosines. I mean sine theta.
3 sine theta. Actually, I don't need to use theta. I use x. I use x. Notice that it actually gives us a sine or cosine function. The graph is like this. So there's a maximum value for the amplitude. You see that? Okay, it's between 3 and 4, right? It's between 3 and 4. Now, I will not derive that for you anymore. What's the maximum value? But I will just do the following. I will just do the following. I will just tell you what is that. The maximum value for this is, the square root of 2 squared plus 3 squared. The 2 squared comes from here, and the 3 squared comes from here. The coefficient of the cosine and sine. Okay, so the minimum distance d will be 5 over square root of 13, which I get from here. That's the closest distance. Okay, now if I make it into a general case in general, if I have ax plus by equals to c, then the distance of this line from origin will be c, actually supposed to be absolute of c, just in case the c is negative, over square root of a squared plus b squared. Okay, that's some topic. There's one topic that I would like to actually go over with you. I don't have a chance, but in that topic, we actually do, one of the conclusions is actually how to find the amplitude of this function. Okay, well, anyway, we forgot about that. Don't worry about that. About this guy. Well, r cosine theta minus sine theta. This is r cosine theta minus r sine theta equals to 2. This will be
X minus y.
X minus y, that's right, equals to 2. Okay. x minus y equals to 2. Actually, by the way, we can actually see this so well. Notice that if I solve for r, I will get 2 over cosine theta minus sine theta, right? Now, what is the closest distance? The closest distance d will be 2 over square root of 1 squared plus negative 1 squared. That's 2 over radical 2, which is radical 2. Right? Now let's confirm that, because this is something we can graph though. This is something we can graph. Let me graph it here. Hold on, give me a second. X minus y. Check a little bit. I wonder if I can do it here. Yeah. Okay, so that's the graph, right? That's the graph. Now, this is 2. That's 2. That's 2 units here. That's 2 units here. That's 2 units here. The closest distance is this. This is the closest distance. You can see that visually, right? You can see that visually? Where am I?
Yes.
Yeah, I'm here and there. Okay, now then, notice that if you apply Pythagorean theorem, this is 1 and this is 1, right? Okay, so the distance d is confirmed to be square root of 2. Does it make sense?
Yeah.
Okay, yeah, it just happened that we can see that here though. Okay, I will go on, I will just leave it here. What do you need to know from this section? From this section, it's just the homework. 8.5b will be, you need to know how to do number 9, number 11. We will graph number 15. Oh, sorry, I looked at the wrong one. Okay. No. That's not what I meant. Number 49, I meant. Number 49, number 51, number 51, and then number 55. Just converting the equation though. And then 57, 59, 61, and 63. Don't forget to do the 63. Okay. Now, then in the next section, 8.6, we will learn to graph. We graph some of them already. We already graphed the important one. For example, we already graphed r equals to constant, theta equals to constant, and then r equals to some number times sine theta, r equals to some number cosine theta. Okay, but we want to graph more. And what is that? I will then teach you to graph, for example, number 16. Number 16, r equals to 4 plus 2 cosine theta. R equals to 4 plus 2 cosine theta. Before I actually graph this, notice that this r depends on cosine theta only. I'm not talking about theta, I'm talking about cosine theta. Okay. Now, because the r, the radius depends on cosine theta, then the graph is symmetric with respect to x-axis. Okay, as if I'm saying the following: because it's symmetric to x-axis, whatever you graph up here, you will copy paste and reflect that. Is it okay? It means I just need to find the angle theta from 0 degrees to 180 degrees. That's good enough. Whatever the graph I have there, I will copy paste and reflect. Are you with me?
You say it again.
Okay, because this r function r here depends on cosine theta. Depends on cosine theta. It means the graph will be symmetric with respect to x-axis. Is it right?
Oh, okay, yeah.
Right? So I can just graph the top part and then flip that later on. But for me to graph the top part, it means I need to graph from 0 to 180 degrees. Now, that gives us the idea. Okay, then I will find the value for r when the theta is between 0 to 180. So 0 degrees, 15 degrees, 30 degrees, 45 degrees, 60 degrees, 75 degrees, 90 degrees, 105 degrees, 120 degrees, 135 degrees, 150 degrees, 165 degrees, 180 degrees. Now, let me ask you to do that one. You will take approximately 4 minutes for this. Just get the value. Just get the value. Okay, let's start. What happened at 15 degrees?
5.9.
Repeat again. 5.9.
Yeah.
30 degrees.
5.7.
45 degrees.
5.4.
5.4. 75 degrees.
4.5.
105 degrees. Should be 3.5. Huh?
Yeah, 3.5.
And then 135 degrees.
2.6.
Huh?
2.6.
Oh, 2.6. 2.6 and then
2.3.
2.3.
2.1.
Okay. Now, I just need to graph the top part, right? Okay, that's why on my screen here, I will just show you the top part. Okay, so when 0 degrees, I get 6, 1, 2, 3, 4, 5, 6. 15 degrees is 5.9, it's very close to 6. And then 5.7, a bit further. And then 45 degrees, 5.4, so a bit less than 5.5. And then at 60 degrees, that's 5. 75 degrees, 4.5. 90 degrees, 4. 105, 3.5. 123. 135, 2.6, a bit more than 2.5. 153, 2.3, a bit less than 2.5. And 165 degrees is 2.1 and then 2. Which if I graph that, it gives me something looks like this. Now don't ask me what it looks like. Okay? Don't ask me. It's just strange. The thing is, this is the type of function that shows up a lot in our calculus 2 actually. Now then, I will reflect whatever I have on the top underneath. So 2.1, 2 point what 2.1 and then 2.3, 2.6, 3, 3.5, 4, 4.5, 5, and then 5.4, 5.7, 5.9, 5.7, 5.9, and then that one. So you see that it's reflection, right? Now in math, we have a name for this graph. We call that limachon. So it's kind of like, you can think of that like a circle, but you push that ball. If this is a ball, you push that a bit from this side here, so it gets a bit squeezed on this side, and the part here gets a bit go further there. You know, imagine if you throw a ball. Imagine if you throw a ball at very high speed. Let's say I have a ball. Okay, let's say, oops, no, not this ball. Doesn't look like that. Let's say I have a ball, okay, and then I throw at very high speed, such that the air resistance actually push this way, right? And it makes this the front part of the ball a bit squeezed in, and the back part of the ball a bit squeezed out, like that. You see what I mean? So you can imagine that's what it looks like. Okay, yeah, you can imagine that's what it looks like. Okay. What we learned from this part is that it is symmetric with respect to x-axis, so we just need to graph from 0 to 180 degrees. Okay, now I would like you to do one more, and the following will be a bit strange. One more. For example, graph r equals to 2 plus 4 sine theta. Now, before you really start, you realize that this function r equals something depends on sine theta only. There's no cosine theta here, and no theta also. It's only sine theta. So then we will see this is symmetric with respect to y-axis. As if we will just graph the one on the right-hand side, and later on we will copy paste that. You see? Okay. Now then, how do we graph the one on the right-hand side? Then we will choose the angle in quadrant 4 and quadrant 1. Okay, we will graph in quadrant 4 or quadrant 1. Quadrant 4 and quadrant 1. Okay, so my theta will be, let's do quadrant 1 first, okay? Quadrant 1 will be 0 degrees, 15 degrees, 30 degrees, 45 degrees, 60 degrees, 70 degrees, 75 degrees, 90 degrees. That's for quadrant 1. And the one in quadrant 4, 270 degrees, 285 degrees, 310 degrees, 300, I'm sorry, I think I need to mistake. Yes, in 300, not 310. 300 degrees, 315 degrees, 330 degrees, 345 degrees, 360 degrees. I know sine 0 is 0, so at 0 degrees that will be 2. I believe that's the case for 360 degrees. At 30 degrees, that's 1/2. So this is 4. This will be 6 here. This will be -2. This will be 0. Ooh. Yeah, you find out the rest. I give you 1 to 3 minutes maybe. So what is the radius? What is the r at 15 degrees?
3.0.
3.0. Let me just call that 3. 45 degrees.
4.8.
60 degrees.
5.5.
75 degrees. Is it 5.8 or 5.9?
5.9.
5.9. Okay, at you know what? Let me do this the one in quadrant 1 first. Yeah. I will do quadrant 4 later on. In quadrant 1, at 0 degrees, that's 2. 15 degrees, that's 3. 30 degrees, that's 4. 45 degrees, 4.8. 60 degrees, 5.5. 75 degrees, 5.9. 90 degrees, that's 6. Okay, and we know that will be symmetric with respect to the y-axis. Okay, so I will just copy paste the one I have on the left hand side. I copy that here, 5.9, 5.5, 4.8, 4, 3, 2. So the graph will be approximately, on the top part will be approximately like this. You see, so I don't waste too much time in getting the value for all those special, or for all those angles, right? Yeah, doing it this way, and I actually save some time, because then by doing the right hand side, I get the left hand side too. Okay, that's what we have. Now what happened at 285 degrees?
Negative 1.9.
Negative 1.9.
Negative 1.5.
Negative 1.5.
Negative 0.8.
Negative 0.8, and then 0, and then I think we should
Just
be
1.0.
1.0. Okay. So using those numbers, at 270 degrees, I shoot backward 2. At 285 degrees, I shoot backward 1.9. 300 degrees, 300 degrees is here. 300 degrees is here. I shoot backward 1.5. And then 15 degrees, I shoot backward 0.8. At 330 degrees, it's 0. And 345 degrees, that's 1. So if I connect the dots, let me use the black color. If I connect the dots, this is what I get. Now copy paste that and reflect that. So copy, paste, and reflect. I will get this, 0, 1. So it will look like this approximately. That's what it looks like. Now notice that when r equals to 4 plus 2 cosine theta, notice that the maximum value here is 2, the minimum is -2. So the maximum for r is 6, the minimum is 2, right? Now, if the minimum is positive, there is no loop. You see that here? Okay, if the minimum is positive, the minimum is 2, that's positive, so no loop. No inner loop, we call that. Now here, for what we have here, we have r equals to 2 plus 4 sine theta. Okay, the maximum is 6. Actually, you can say the maximum is 6 at 90 degrees, right? The minimum, however, is negative. -2. Now, once the minimum have -2, then we have inner loop. It has inner loop. Okay, in general, we can say the following. In general, if we have r equals to a plus b sine theta, that is symmetric with respect to which axis?
Y.
Y-axis. R equals to a plus b cosine theta, that will be symmetric with respect to x-axis. Now when a is greater than b, maybe I say the magnitude of a is greater than magnitude of b. Or let's just assume a and b positive. Okay, let's assume a and b are both positive, and a is greater than b. If a is greater than b, then the minimum will be positive. Minimum will be positive, therefore no loop. Now, if a equals to b, exactly equals to b, so the minimum will be 0. Still no loop, it's still no loop, but touch origin. It will touch origin. Now, if b is greater, it means the minimum is negative. Then we will have has inner loop. Okay, now let's do graphing. This way we can do it a lot faster. Okay, so suppose I have r equals to 4 plus 2 cosine theta. This is what we saw earlier. This is what we saw earlier. Notice that cosine theta, that will be symmetric with respect to x-axis. If I change this to sine theta, it's symmetric with respect to y-axis, right? Now, suppose I change, becomes 3 plus 3 cosine theta. Symmetric to which axis?
X.
The x-axis. Do we have a loop?
No, but they'll touch at the origin.
We'll touch the origin. Okay. Now, suppose I make the coefficient of cosine smaller. Now you see that it is possible this becomes -3, such that the total radius becomes -1. So we have, yeah, then we have a loop. Okay. Now here's the thing though. In my calculus 2 classes, I have some students when they see this, they don't know what it looks like. I don't need them to be very precise what it looks like, but at least have some feeling. For example, suppose, let me go back to this here, to our note. Suppose, for example, I ask them to do a rough sketch. For example, R equals to 5 plus 3 sine theta. They have no clue at all what to do. And I hope you at least have some idea. What idea? Well, we know it will be symmetric with respect to
The y-axis.
y-axis. So I just need to do one side, right? Okay, when theta equals to 0, it's 5. When theta equals to 90 degrees, that's 8. Let's say it's here. Okay, and then when theta equals to -90 degrees, that's 2. So you expect the graph to be like this. I say just rough graph, right? So at least you tell me that, oh, it's symmetric with the y-axis and it doesn't have a loop. I can even say that the furthest it can go is 8, the closest it can come is 2, right? Okay, you see what I mean? Now I have students who, in my calculus today, when they see this, they have no clue at all. Now, mind me that it's not that I didn't go over with them. I went over this with them. Of course, I went over this with them quite fast. But what happened in their situation is they have never seen this at all, such that even if I review it, they still don't get it, you know. And that basically disabled them from going past my test 3. So once we are done with test 3, they drop class. They just cannot handle it, you know. Okay, so what do we do in this section? What I want you to learn, suggested homework. Suggested homework 8.6. I would like you to do number 13, 15, 17, 19. You can try number 23. Number 23. Number 45 is kind of hard to grasp it. Number 33. Only 6 questions. We have a test. Repeat again.
This is the last section for the entire semester?
Yes, that's right. Okay. Now your test 4 will be starting from where? Let me see again. I believe your test 4 start from chapter 7. 7.1 up to 7.3 or 7.4.
7.4.
Up to 7.4 only. And then for chapter 8, that will be 8.2 to 8.5 only. Okay, now how about 8.6, Thomas? 8.6, I will give you a quiz. No, I don't want to call it quiz, a take-home quiz. Take-home quiz. I think I will post it on, maybe remind me if not, I think I will post this on Saturday. But do on June the 1st. So the Monday after your test 4. Is it okay? So this 8.6 should not get into your way of studying test 4. But I gave it to you this Saturday anyway, and you have 9 days to do it. Is it 9 days? Yeah, you have 9 days to do it. Just in case that during the Memorial Day, you want to do some trigonometry. That will be surprising, but I will be so happy though. Yeah, okay?
I'll put it in on Memorial Day just for you.
Okay, I hope that's all. Do you have any other question?